Welcome back to my physics class. In today's video, we are going to be discussing motion graphs more in detail. The notion of a value being a scalar quantity or a vector quantity was introduced earlier in a previous class. The key to remembering the difference between the two is that a vector quantity has a direction. Think of a vector array that you've encountered in the math class. In scalar quantities, we only have magnitudes, or essentially numerical values only, whereas a vector has both the magnitude and the direction. For each example, we have their units listed in parentheses. Note the similarity between speed and velocity is that they both have the same units, which is meters per second. The difference between the two is that we see a negative symbol for velocity, which indicates the direction for us in this case. Remember that you cannot go negative speed. So the 5 meters per second is your speed. However, the negative indicates the direction as either being left, down, or backwards. We also have negative acceleration, the acceleration due to gravity. The negative means that it's coming downwards. Remember that gravity pulls everything downwards, so everything accelerates at 9.8 meters per second squared, but because it's accelerating downwards, that is denoted by a negative symbol. So therefore, we have negative 9.8 meters per second squared as the acceleration due to gravity. Here are some very simple vectors for velocity. Notice that the values have a sign, positive for A, negative for B, and the arrows are proportional to the magnitude of the vectors. Positive 10 meters per second is twice the size and in the opposite direction as negative 5 meters per second. We are going to study two kinds of motion graphs. The first one being position versus time, also known as displacement versus time, and the second one being velocity versus time. The first type of graph that we will look at is the position versus time graph. Notice that position in meters is on the y-axis and time in seconds is on the x-axis. But on this graph, there is an extension of y-axis below 0, and the values are negative. This is not different from the negative values you've learned about in math. We will look at the graph in sections after learning about what the slope of a position versus time graph tells us about the motion of an object. In position versus time graphs, the slope represents either the speed or velocity. Remember that speed is always positive because it is a scalar value, whereas velocity can be negative because it includes our direction. Just as a reminder, you can always calculate slope when you have 2 points in a graph by going m equals y2 minus y1 over x2 minus x1. The slope of a position versus time graph will tell us if the object is moving, whether that's constant speed or velocity, if the object is stopped, and the direction in which the object is moving. A positive slope means that it's going forward, up, or right, whereas a negative slope means that it is going backward, down, or left. The slope in a graph will tell us an object's displacement over time. How can you tell if the object is moving? The object is moving if the slope does not equal 0. If the line is not flat or parallel to the x-axis, then the object is said to be moving. How can you tell if the object is going forward or backward? The object is going forward as long as you have a positive slope, and the line is going towards greater or larger positive values. The object is considered to be going backwards as long as you have a negative slope, and the line is going towards greater or larger negative values. Now that we know some basic information, we can go ahead and look at this graph in each section. From 0 to 10 seconds, the object is moving forward. From 10 to 20 seconds, the object is stopped because the line is flat, parallel to the x-axis, and the slope is 0. At the 25-second mark, we can see that the object has returned to the origin, or where they started from, and is continuing to go past that point. From 20 to 35 seconds, the object is moving backwards. And from 35 to 40 seconds, the object is again stopped because the line is parallel and the slope is 0. Let's look at a real-life scenario with a basketball player at midcourt. The midcourt is considered 0-0 or the player's starting position. From 0 to 10 seconds, the player moves forward 2 meters. From 10 to 20 seconds, the player is stationary and stopped in place. At 20 seconds, the player runs back towards his own court in order to stop a fast break. At 25 seconds, he is back at midcourt, which was his starting position, and continues to run into his half of the court from 25 to 35 seconds. At 35 seconds, he realizes that his career is in jeopardy as he's going to get posterized. Therefore, he has a change of heart and decides to stop in place from 35 to 40 seconds. For those of you who may not be familiar with the term posterize, this is the infamous dunk of death by Vince Carter over 7'2" French player Frédéric Weiss in the 2000 Olympics. So now hopefully you can understand why our player decided to stop in place from 35 to 40 seconds during the fast break rather than contesting the dunk. Now let's go ahead and focus on velocity versus time graphs. In a velocity versus time graph, the slope represents acceleration, and the units for acceleration is meters per second squared or meters per second over seconds. Always look at the units carefully and don't confuse the units of acceleration, which is meters per second squared, with the units of velocity, as you will see on the graph, which is meters per second. The slope and the graph will give you many different pieces of information. For example, it will let you know if the object is stopped, whether it is increasing or decreasing velocity, and the object is always considered to be accelerating if your slope does not equal 0. The line on the graph will tell you if the object is moving at constant velocity, which is moving at the same speed and same direction over an amount of time. In addition, if velocity is equal to 0 meters per second, the object is stopped or stationary. A key thing to remember from this is that 0 meters per second is also considered as a constant velocity value. Now let's go ahead and look at each section of this velocity versus time graph. Notice that velocity in meters per second is on the y-axis and time in seconds is on the x-axis. Another key detail to pay attention to is that both -5 meters per second and 5 meters per second are considered as slow velocity compared to the greater values of -15 meters per second and 15 meters per second. Remember that the negative is simply indicating the direction for us. Therefore, an object moving with a velocity of -15 meters per second is moving at a faster rate than an object with a velocity of +5 or +10 meters per second. Let's look at each section individually, and I will show you an easy way to remember all of this info shortly. In section A, the object is moving forward and increasing its velocity. At 0 seconds, the velocity was 0 meters per second, but it increased to 10 meters per second at 2 seconds. In section B, the object is still moving forward, but at a constant velocity of 10 meters per second from 2 to 3 seconds. Do not confuse this flat line with one from the previous position versus time graph. In section C, the object is still moving forward, but is decreasing its velocity from 10 meters per second at 3 seconds to 0 meters per second at 4 seconds. Do not confuse the negative slope from 3 to 4 seconds in this velocity versus time graph to a negative slope in a position versus time graph. In section D, the object is stopped or stationary as velocity is equal to 0 meters per second. Remember that from 4 to 5 seconds, the object has a constant velocity of 0 meters per second. This is the only time in which an object is stopped or stationary in velocity versus time graphs. In section E, the object is moving backward with increasing velocity. At 5 seconds, the velocity was 0 meters per second, and it increased to -10 meters per second at 6 seconds. Remember that the negative is indicating the direction for us, and -10 meters per second is considered as faster velocity than any value ranging from -9 to 9 meters per second. In section F, the object is still moving backwards, but with a constant velocity of -10 meters per second from 6 to 7 seconds. In section G, the object continues to move backwards while decreasing its velocity from -10 meters per second at 7 seconds to 0 meters per second at 8 seconds. Finally, in section H, the object is now moving forward while increasing its velocity as we see the line go towards greater or larger positive values. At 8 seconds, the object had a velocity of 0 meters per second and quickly accelerated from 8 to 9 seconds, increasing its velocity to 15 meters per second at 9 seconds. Now I understand that was a lot of info at once, so let's go ahead and show you some easy ways to understand and read a velocity versus time graph. First, let's look at how you can tell if an object is moving in a velocity versus time graph. The object is moving as long as you don't have a flat horizontal line on the x-axis. So the object is moving with any value other than 0 meters per second. As you notice on the graph, everything that is highlighted is considered to be moving, except for section D, as it is on the x-axis. Again, don't confuse flat horizontal lines in a velocity versus time graph to those in a position versus time graph. Now let's look at how you can tell if an object is moving forward or backwards. Remember that in physics, right, up, and forward are always positive, and left, down, and backwards are always negative. Think of the x-axis as a division line in a fraction, and it divides our graph into top half and bottom half. Section D is not part of either the top half or the bottom half, as it is on the x-axis itself. So any line that is on the top half of the graph is considered to be moving right, up, or forward. The easy way to remember this is to pronounce the mnemonic of RUF as roof for the roof of a building, since a roof is at the top of a building. Now that you know anything on the top half is right, up, or forward, anything on the bottom half of the graph will be the exact opposite, which means it will be left, down, or backwards. As we look at the highlighted sections of E, F, and G, they all have a negative velocity value and are in the bottom half of the graph, which indicates the object's direction as backward, left, or down. Hopefully this lesson has been helpful in clarifying the differences between position versus time graphs and velocity versus time graphs. Don't forget to hit like and subscribe, and have a wonderful day.